My name is Melita Mokos. I'm a marine biologist. I work at the University of Zadar in Croatia at the Department of Ecology, Agronomy and Aquaculture. And been involved in ocean literacy for almost 10 years. So today I'm gonna continue the discussion on ocean literacy principles and talk about ocean literacy principle 4 and 5. So for the beginning, the ocean literacy principle 5 refers to the fact that the ocean makes Earth habitable. So what does that mean, and how come that ocean makes Earth habitable? As far as we know for now, Earth is the only place in the universe and the only planet in the universe that has life on it. And not any kind of life, like very simple forms, but very, very complex life forms from microorganisms to humans. So it's really a huge diversity of organisms that evolved on Earth, but also um, ecosystems and so on. So, what is it that makes Earth so special and unique in the universe and provides opportunities for such evolution and development of life? If you look at this picture, I don't know, maybe some of you had the chance to see this photo before, maybe some of you haven't. Whenever I look at this photo, I always think that this little white dot is a particle of dust, and I, start to take it off the screen, and then I remember that's us. This picture and this little white dot presents Earth far away from space. It's also called the pale blue dot. This is where we all are. This is where everything we know about is. And it's really unique and very, very different from everything else that we know about universe. When we come closer to our solar system, it is also unique because there are a lot of planets around us, but on none of them there is, for now, evidence of life or that it ever existed. So it's really something that makes us wonder, what is it that makes Earth so special, and how come that life evolved only on Earth? So again, what is the reason? And the reason for that is the existence of water. The existence of water, of liquid water, is something that provided opportunity for complex chemical reactions, interconnections between molecules at the level of the cell metabolism and so on, to develop so many different complexities, and then to have development of different life forms. So liquid water, and as we know, is the one that provides so many opportunities for so many different processes, which then lead to development of different life forms. So we know that first life originated in the ocean, and the reason for that, and the reason for the development of life later on, was the oxygen production. And the baseline for that was the process of photosynthesis that started to happen in the ocean. So principle 4 contains only 3 concepts, and we're going to go through each of them shortly and explain a little bit about it. So the first concept related to principle 4 refers to the fact that most of the oxygen in the atmosphere originally came from marine photosynthetic organisms. So how did that happen? I guess all of us are aware of the process of photosynthesis. And the process of photosynthesis is basically the fundamental process on Earth that provides opportunities for the development of such complex and life, which is spread all around the globe. When we think of marine environment, which are the organisms that do photosynthesis? We usually, and I think also when you talk to your students and your kids about it, in the minds of people, the photosynthetic organisms, the microphotosynthetic organisms that live in the sea are really not the organisms that people like. So it's that slimy and yucky seagrass and algae that live in the sea. But they are very, very important because they have the opportunity, the power to produce oxygen in the sea. Most of the oxygen in the sea is produced by tiny little plants that are called phytoplankton. I guess most of you also are aware of the cartoon SpongeBob. SpongeBob is very favorite cartoon for many kids all over the world, and they always. This is what I use also when I do some stuff and activities, workshops with kids, to make the photosynthesis process and phytoplankton closer to the minds of people and to the minds of kids. So photosynthesis is at the baseline of life on Earth. It is strongly dependent on the light availability, and that's why in the sea it is it happens in the layers which have more light. So most of this oxygen today that we have and that we breathe is the oxygen that was generated by photosynthetic organisms long in the past, in geological past of Earth. And then this oxygen accumulation also in the atmosphere enabled life on terrestrial on the land to develop. So when we talk about and when we think about life on land, it doesn't include only terrestrial organisms, but also we know that there is also freshwater on land. So it also includes freshwater organisms and ecosystems. So those organisms that provide oxygen in freshwater systems, but also in marine ecosystems, are phytoplankton. We also have algae, microalgae or seaweed, and in the sea we have seagrasses. Seagrasses are actually real plants that through evolution came back again to the sea. So it's really complex, diversity of different life forms that produce oxygen, and this is what is at the baseline of life on Earth, and that is why ocean makes Earth habitable, because marine organisms, mainly microbes, including cyanobacteria and phytoplankton, actually produced huge amounts of oxygen, which then accumulated in the atmosphere and enabled life on land to develop. There are also some evidence and some of the oldest living forms on Earth found that are actually accumulated cyanobacteria. So they're fossil cyanobacteria and can be they're called stromatolites. And they are mostly found in Australia. So these are fossils of organisms that lived 3.5 billion years ago on land, and that's on Earth. And that's when actually the first life started to develop in the sea. On the other hand, today the communities of different photosynthetic organisms change through time. And today we have this very, very tiny and small, but yet so important phytoplankton organism, which is called Prochlorococcus marinus. You don't have to remember the name, but these tiny little cyanobacteria are the ones who produce most of oxygen in the sea. And that's why they're very, very important, because they have huge a role in the oxygen production in marine ecosystems. Apart from producing oxygen that organisms breathe, this phytoplankton organisms once produced oxygen, which was shifted from marine environment into the atmosphere. But in the past times, long time ago, the atmosphere was not as it is today, and there was no ozone layer. We know how important ozone layer is for the protection of living organisms from negative sun radiation. So as the oxygen accumulated in the atmosphere, it through different chemical processes under the impact of sunlight, sun radiation, it changed from a regular oxygen molecule to ozone molecule, and then ozone accumulated in the atmosphere as well, and the, that shield around the Earth was formed, which then protected life on Earth and from the negative or ultraviolet radiation from the sun, and that also enabled life on Earth to develop and to evolve into more complex organisms. So production of the oxygen that is used by organisms for respiration that we breathe, but also the formation of ozone is important for development of life and making Earth a habitable place. Apart from those stromatolites that I just mentioned, there's also a theory recently that there's a possibility that life on Earth also was created not in the shallow water, in the photic zone where you have a lot of sunlight, but in the deep, deep ocean where there is no sunlight. How is that possible? We know that on Earth's surface, life is very dependent on the process of photosynthesis and on light. But in the deep ocean, couple of thousands of meters depth, there is still abundant life, diverse life. There are special places in the deep ocean that are based not on photosynthesis but on chemosynthesis. But we will talk about this in the principle number five. So there is a recent theory so that the evolution of life was actually started in the deep ocean in the places called hydrothermal vents, where there's no sunlight, where the energy is not used from sun, but through by different chemical reactions, and it's really something that is currently being used to search life on other planets and on other places in the universe. So once the first life started in the ocean, it evolved through million years. From then, and organisms shifted and evolved from the sea and moved to the land, and then some groups of organisms came back again to the ocean. Like today we have sea mammals or we have seagrass and so on. Those organisms were the ones that lived, that moved through the evolution from the ocean to the land and then came back as well. The ocean provided in the past and continues to provide water, oxygen, and nutrients, and it impacts and moderates climate on Earth. So these are all prerequisites for development of life. If there is no water, there is no life. We need oxygen, we need nutrients, and we know that the ocean is a regulator of climate on Earth. So this was also mentioned in some of the previous principles. So just to keep in mind that through different, as Francesca mentioned, to different cycles, to different chemical processes, such as the photosynthesis, through sea current circulation, to water cycle and all other kinds of cycles, we are really and strongly connected to the ocean. We don't have to be connected directly in a way that we see, like when we eat fish or we eat submarine products or we swim in the sea. These are not the only connections with the sea that we have. One of the main connections with the ocean and with the sea is the water cycle, because most of water that evaporates from the ocean and forms the rain comes from the tropical part of the ocean. And I think Yolanda mentioned that before, because that is the area which is most heated by sun. So that's where most evaporation happens. So when we think about all of these let's say, services that the ocean provides, that is how the ocean make Earth habitable. I won't go into details. There is a link, as also Francesca posted it in her slides, where you can see and find scope and sequence and all these issues related to this principle for different grades range. So you can take a look at there. Here, I wanted to share some of the examples that I used when I was working with students. Water cycle is really something that is very common to them, but it can be done in very different, interactive, and fun ways. Lego bricks are always like the top material that you can use. But what was really interesting in one section was doing the water cycle with the little beads that actually we made bracelets from. So each color was representing a certain stage of water cycle. So it was not like, it was really like a strict way of putting these beads and following the water cycle steps to make this bracelet. So it was really interesting and fun. And then in the end, they had some souvenir to take home too. So it was one activity, and one thing that we always kind of, when we talk about these topics, we usually refer mostly to biology, to maybe to chemistry, but it's really these topics like water cycle or photosynthesis, they can be done by covering so many different subjects in school. So for instance, here, this is the song. Yeah, I will not show it to you now. You can take a look later on your own. But this is a song about photosynthesis, which is really so catchy. And when I first listened to it, I still have it in my mind for years, And it can cover different subjects such as language. So most of you are not native English speakers. So you can always combine foreign language, like in this case, English, and then the science, and then music, and do something with the artistic at the end, and so on. So it's really different subjects that can be really easily connected through these kinds of activities. And here's also a link to the handbook for teachers from the European Blue Schools, where you have all kinds of projects, examples of projects and activities that are also related to other principles, but also to the principle number 4. That's it for the principle number 4 from me. I'm done.